IISER Pune Science Media Center presents Experimental Particle Physics at IISER Pune with Professor Sourabh Dube.
Hello, my name is Sourabh Dube and I am an experimental particle physicist. I started at IISER in the year 2013 as an assistant professor after working as a Chamberlain Fellow at Lawrence Berkeley Lab for 4 years. I first came to know of IISERs when the then director of IISER Trivandrum, Professor Jemis, visited UC Berkeley. The IISERs to me seemed like a great idea to bring research in pure sciences to the undergraduate level in India. When I applied to IISER Pune, there were no experimental particle physicists at any of the IISERs. But the chair of the physics program, Professor Sunil Mukhi, he encouraged me a lot, and the director, Professor Ganesh, has been very supportive. Today, IISER Pune is the only IISER to have an experimental particle physics program. I spent my PhD thesis looking for signs of supersymmetry at the CDF experiment at Fermilab in Chicago. Subsequently, I searched for microscopic black holes at the ATLAS experiment near CERN. But what I really honed were my skills in searching for new particles using leptons. When I started at IISER Pune in August of 2013, very soon I had a group of motivated graduate and undergraduate students. Along with my colleague Seema, I then petitioned to join the CMS collaboration at CERN. CMS is a giant collaboration which involves over 100 collaborating institutes from all over the world. CMS acts like a giant detector which takes a picture of the debris when two particles collide. Dedicated software written by scientists like me then tries to examine the debris and figure out what happened during the actual collision. An experimental particle physicist aims to discover new fundamental particles and also aims to measure the quantum properties of these particles as precisely as possible. The 2015 Nobel Prize was given for the discovery of neutrino oscillations. This discovery happened the year I started working in particle physics. Our existing theory, the standard model of particle physics, cannot explain neutrino oscillations. We have several possible solutions to this problem, several ways of modifying the standard model. The trouble is in finding the right solution. I and my PhD students decided to tackle the neutrino mass problem by looking for a particular model called the type 3 seesaw model. This model predicts the existence of new leptons. We would look for evidence of these leptons in the proton-proton collision data collected by the CMS detector. I have entered into a collaboration with Professor Somola's group at Rutgers University, and together our groups have started to analyze the data collected in 2015. Earlier this year, we showed the results of our search in a physics analysis summary note. This year, we will collect up to 10 times more data. Aside from the type 3 seesaw model, the data may hold surprises that we don't anticipate. While performing these studies, I have to keep one eye on the future as well. The high rate of collisions causes significant wear and tear of the CMS detector. My colleague Seema and I are already thinking about the upgrades to the detector that will be necessary in the next decade. Later this year, we will begin our research into improving the data acquisition system of CMS by putting together a mock-up in our lab at IISER. In addition, we will also put together a CMS center that will help us to remotely monitor the collection of data and the status of the various components of the experiment. Speaking of the future, IISER Pune has now added a theorist, Arun Thalapillil, to the faculty. Arun has expertise in the theoretical implications of the LHC data. These coming couple of years are going to be vital. We are going to see a massive search using all of the LHC data to try to pinpoint the right solutions to the various problems of the standard model. Whether the solution is among the anticipated ones, such as supersymmetry, or if it's a truly unanticipated surprise, either way, the hunt is on. I and my group here at IISER plan to be at the forefront of this voyage into uncharted waters.